7.6 is our next section, and it is to solve exponential and logarithmic equations. So there's two properties of equality, or I don't know, just informational things, I guess you could say, that you need to know out of this section, and then we'll just go through and do several examples. So property of equality for exponential equations. So this says that if b is a positive number other than 1, then b to the x is equal to b to the y if and only if x is equal to y. So remember, IFF is if and only if x is equal to y. So an example of that would be if we had 3 to the x is equal to 3 to the y, then x is equal to y. Okay, and the reverse is true. If x is equal to 5, then 3 to the x is equal to 3 to the 5. Okay, so that's the first one. The second property, so that's for exponentials. Property of equality for logarithmic equations. This one says that if b, x, and y are positive numbers with b not equal to 1, then log base b of x is equal to log base b of y if and only if x is equal to y. So, examples of that would be if log base 2 of x is equal to log base 2 of 7, then x is equal to 7. Or if x is equal to 7, then log base 2 of x is equal to log base 2 of 7. Now, the only other thing with these is that we can have extraneous solutions. Okay, so we have to check for extraneous solutions with this type. And we do this by plugging in the answers to the equation. Plugging in the answers to the original equation. Now, I will tell you one thing that should be an automatic clue. The log of a negative number is a non-real answer. So we cannot have the log of a negative number. Okay, so that should be the easiest way to find one, but you do have to check them, okay, to show that. But I just wanted to make that comment because I don't think I had made that when we actually talked about logarithms. So we're going to look through a little bit of each of these types here that we have and solve some equations. So let's start with the stuff like 3 through 11. See, which one do we want to do? Guess let's just go ahead and start with 4. Alright, 7 to the 3x plus 4 is equal to 49 to the 2x plus 1. So, my first thing would be to check, are these the same? Well, no, not yet. So what I need to do is I need to rewrite these in terms of something that I know so that they are the same. So what I would recommend doing, I know that 7 squared is 49. So I'm going to replace 49 with 7 squared. So it's going to be 2 times 2x plus 1 in the top now, okay, because I just made 7 squared raised to that. Now these two bases are the same. So I can say 3x plus 4 is equal to 2 times 2x plus 1. And this is 3x plus 4 is equal to 4x plus 2. I'm going to move my x's to the left side, so that's going to be negative x is equal to, I'm going to subtract this 4, negative 2, so x is equal to 2, and that would be our answer. Okay, so these you just have to end up rewriting them, and then you just set the top stuff equal to each other and solve like normal. Now with these ones, we don't have to check for extraneous solutions, okay, because they're exponents. There's no stipulations on what can and can't be in the exponents. So we're good on there. Let's see. So what if we have something like 6, though? 6 is 27 to the 4x minus 1 is equal to 9 to the 3x plus 8. Well, 9 and 27, their only relationship is using 3. So I could rewrite this as 3 cubed and 3 squared, which would probably be my best bet. So 3 to the 3 times 4x minus 1 is equal to 3 to the 2 times 3x plus 8. Now I have the same base, so I can set these two things equal to each other. So 3 times 4x minus 1 is equal to 2 times 3x plus 8. So now I'm going to distribute here. So 12x minus 3 is equal to 6x plus 16. Subtract 6x. So that's going to be 6x is equal to, I'm going to add 3. It's equal to 19. And then divide by 6, x is equal to 19 over 6. Okay, so sometimes you will end up with a fraction, and that's fine with these ones. Now, I say you don't have to check for extraneous, but if you did want to check your answer, obviously you could plug these in and make sure these two sides come out equal. But overall, you shouldn't really have to do that. So let's do one more of that type. We're going to look at number 10. So 10 is 10 to the 3x minus 10 is equal to 1/100th to the 6x minus 1. Okay, so again, these obviously aren't the same here. So I need to try to do something here to fix that. Well, I know that 100 is 10 squared, but this 100 is on the bottom, so I could write it as 10 to the negative 2. So 10 to the 3x minus 10 is equal to 10 to the negative 2 times 6x minus 1. Now I have the same base. So 3x minus 10 is equal to negative 2 times 6x minus 1. So I need to distribute over here. So 3x minus 10 is equal to negative 12x plus 2. So then I'm going to add this 12x over, giving me 15x. I'm going to add this 10 over, giving me 12. So then x is equal to 12 over 15, which simplifies down into, see, I can take out a 3, so 4 over 5. Alrighty, so that's those ones. So now let's jump to stuff like 12 through 23. So solving exponential equations. Okay, so this stuff was solving the equations, but over on this next step, we actually want to get a value for it. We want to know what it's actually equal to. So with stuff like this, we start out with something like 12 is 8x is equal to 20, or 8 to the x is equal to 20, sorry. Okay. I wager to say you don't know 8 raised to what power is equal to 20. However, if you remember back to what we did in 7.4, okay, with changing things from exponentials to logs and logs to exponentials, okay, with that making the L and making the E, we can do that here. So I can draw down through the 8 over to the 20, back up into the x. So this gives me log base 8 of 20 is equal to x. Okay, based on using this L method here. Now I can go to my calculator. I can use the math function, arrow up to log base, can type in 8, can type in 20, 1.44. So x is equal to 1.44. And that's all we're going to do there. So let's try 14. So maybe with 14, this would be a good time when I put up the problem, kind of pause the video and see if you can work it. 14 here. So 14, 7 to the 3x is equal to 18. So I would say pause it and see if you can follow this step here. So come down through the 7, over to the 18 and back up. So this is log base 7 of 18 is equal to 3x. But I need to get rid of this 3 over here because I need to get x by itself. So I'm going to divide this whole thing by 3. So log base 7 of 18 all over 3 is equal to x. So now, over here on the calculator, it might be a little dark, but I'm trying to make sure you can see the problem in that. I hit math, up to log base, 7 of 18. So that number, but then I need to divide that by 3, is minus, and that's going to be 5, or sorry, not minus. X is going to be equal to about 0.50, okay, because of that rounding thing. Let's see. Let's go with 18. and that'll be our last one out of this section, and then we'll go to solving logarithmic equations. All right. Let's see, what did I just say? 18. 10 to the 3x plus 4 is equal to 9. So I still want to solve the same way. So I'm going to subtract 4 over. So I'm going to get 10 to the 3x is equal to 9 minus 4 is 5. So now make my L. So log base 10. So I don't even need to write the base 10 because I already know that's the common log. So log of 5 is equal to 3x. Divide by 3. So log of 5 over 3 is equal to x. And remember, this now is the common log, so I can just use the log button here. Now, there's nothing wrong with using the log base and typing in the 10. Okay, this is just a shortcut. So log of 5 divided by 3 is 0.23. So x is equal to 0.23. And that's all you need to really be able to do for that one. I'm not going to give you any of the really hard ones there. Okay, so 24 through 31 is going to be the last stuff we do. 32 through 43 basically follows the same procedure, but in terms of just the sake of time and everything, since we're not actually in school doing these, we're just going to do the more basic ones like 24 through 31. Go ahead and get a new page here. So remember, with these ones, we have to check for extraneous solutions, and the instructions do remind you of that. So, 24, we have log base 5 of, 5x plus 9 is equal to log base 5 of 6x. So, because based on our property, these are both log base 5, so I can just come over here and say then that 5x plus 9 is equal to 6x. Just because I only have a number, like a 9 over here, and I don't have any numbers over here, I'm going to move the x's to the right this time. But so 9 is equal to 6x minus 5x is just x. So x is equal to 9. That one's relatively easy. We'll do 26 just because it's an ln, but it doesn't change anything. ln of x plus 19 is equal to the ln of 7x minus 8. Now, both of these are natural logs, meaning they're log base e. So I can just say these two things are equal to each other. So x plus 19 is equal to 7x minus 8. So I'm going to subtract the x. I'm just going to go ahead and move this stuff over this way, okay, just because that's where the bigger amount of x's are. So this would be 6x. If I add the 8 over, that gives me 27. Yeah, 27. Divide by 6. X is equal to, let's see, 27 over 6. I can take out a 3, so that gives me 9 over 2 is equal to x. And let's see, really what I should have been doing, and hopefully you just caught that because just flying through it and not paying attention, I should have gone back and checked my answers. So, log base 5 of 5 times 9 plus 9 is equal to log base 5 of 6 times 9. Log base 5 of 45 plus 9 is 54 is equal to log base 5 of 6 times 9 is 54. So in this case, we're good. We don't even need to actually solve that out. we can just say there that we verified it. So hopefully you caught my mistake. But let's go ahead and check this one as well. ln of 9/2 plus 19 is equal to the ln of 7 times 9/2 minus 8. So let's see, if I put 19 over 2, that takes me up to 38 plus 9 would be 47 over 2 is equal to, well, that's 63 over 2 minus, let's see, over 2, that would give me 16. And again, that gives me the ln of 47 over 2. So that one's good. So we've checked it there. Hopefully I don't forget to check the next problem that we do. So let's do 30. And then we'll be done. So 30 is log base 6 of 3x minus 10 is equal to log base 6 of 14 minus 5x. So, same log, same base. So I can say 3x minus 10 is equal to 14 minus 5x. Add the 5x over, so 8x is equal to 14 plus 10 is 24. So x is equal to 3. So now let's check it and see what happens. So log base 6 of 3 times 3 minus 10 is equal to log base 6 of 14 minus 15 times 3. Well, in this case, I get, let's see, 9 minus 10 is log base 6 of negative 1 is equal to log base 6 of negative 1. It's supposed to be a 5 times 3. There we go. Now, those are the same. However, those are not true. And here's why. Math, log base. For one, you should notice, like I said, that there's a negative there, which is why I pointed that out. But log base 6 of negative 1, it's going to tell you there's a non-real answer. Okay? So it's not true. Therefore, this is extraneous, meaning no real solution. Alright. So, that being said, your homework for this section is 3 through 3 through 19 odd, or wait, yeah, let's go 3 through 19 odd, and then 25 through 31 odd. Okay, I really want you guys to make sure you understand how to solve these equations because this will become very important in pre-cal and calculus. Really in the rest of your math career, being able to solve equations like this and understanding it. So make sure you do that. And really these 25 through 31 is probably what's going to take you the most time. These will probably take you the same amount of time as all of those ones. So if you have any questions, remember, let me know, especially before the quiz, so I can adjust, make notes on your homework or something like that so that I can see where you have questions and try to address them before I give you guys your quiz next week. So have a great day.